G'day and welcome back to the human Ransource machine. Let's get going. Let's get back to the business of programming with the Vowel Incinerator. Hey Sil, what's the meaning of this? Ahem. Management is attempting to reduce bandwidth by removing all vowels from every word. Good luck. Okay, cool. So we got a search here, and it's pretty much a case of wanting to store what we're going to compare. So this is going to be X, and this is going to be I. So we start off by getting the input, and then let X be the input. Okay, now what we also want to do is we want to copy from there. Well, I'm actually going to do this first. Copy from 5 and put that in I. Let I equal 0. Okay, so now we've got X. Then what we're doing is we are going to go sub I, check to see, we sub I. If 0, we go back to the start. Everything's done. But if I is not 0, we have not found a vowel, and we want to bump I, right? And this should be sub I, sub what I is pointing at. Bump I, copy from X, which is our search, and then we want to go back to here. But what we also want to do is first go copy from I, copy from 5. No. I'm going to copy from what I is pointing at after that bump. And if 0, we want to go copy from X and outbox. If it's not 0, we want to go back to here. And we need to copy from X. But the problem is what we want to compare is this. And if it's all done, we go back to the start. Let's go. So we're initializing. We got I. Nope. Why are you copying from... Oh, because bump already gives us I. Excellent. Nope. Can't sub with mixed... Hey! That is wrong! So the check for 0, bump I, if... Wait. Let me... Okay, yep. Copy from X. So it's not 0. We get a 5 because we bumped it. Copy from X. Why is this jump back to the start here? Because this is bump I. Oh! Actually, what I want to compare here is I want to get what I is pointing at. So that's why that's not working. Copy from index I. There we go. Now let's check O. There we go. Yes. Yes, it all works. Excellent. So let's kick it up. Let's see it get through everything. Yep. There we go. Yes, my machine, it works! It works! All of the vowels, they are eradicated. They are incinerated. 14 commands. Oh, wow! Yeah, if I can get it to be one fewer command, assuming that doesn't break other things, that'd finish it. Okay, duplicate removal. Yeah, 35. We've been with this company for ages. You're fired! Haha, just kidding. But I do have a note here from your other supervisor. She's out sick today. You sure she's out sick and not out of the building? But she says, it's time to eliminate inefficiencies. And that's it. Send everything from the inbox to the outbox unless you've seen the same values before. Discard any duplicates. Okay. So, what we're doing then is we start with inbox, copy to where 14 is pointing at, and then what you do is, yeah, because you gotta have a place to put it, don't you? So this will be I and this will be X. Okay, because we now need to search. I'm actually kind of puzzled as to how I'm going to do this. One option is basically to build a setup with a zero terminating string, because we can't reference something that it doesn't have anything in it. So if we start off and we put 0 here, right, we actually copy from 14 and copy to here. And then what we have is we have a search where we inbox, we put what we grab from the inbox into our X value, because that's being our variable. And then what we can do is we can search, and we can set it up such that it'll search until it hits a 0. If it's found it, then it goes back. In fact, at any point when it finds it, it goes back to the start. But otherwise, what we want is we want to copy from, copy to X. But otherwise, what we then want to do is we want to search until we hit 0. If we haven't found it, put it in where the 0 was. If we have found it, put it back. The other option is you use this as your pointer to the end of the string. Right, because if this is end, right, then we can always, like, we know where the end is, and if we're at a position, so this would be I, we're at the position of end, then we know we're fine. So I actually think I'm going to try that. So we got end. And so we start off, we copy from end, and we copy to I, which is our position. Because that requires fixed space. The problem then becomes, how do we know what the start is? Because we don't have a reliable way to go to the start. So unless I actually have an I and a start value, that actually doesn't help. So I think this should actually be fixed. Yeah. I don't even know what I was calling it before. We want to actually have a terminator. So yeah, this is just 0. Okay, so we copy from 0, we copy it to the very first, to wherever a 0 was pointing, which is going to be here. We just want to initialize everything. Copy to 0. Copy to I think. Okay. Anyway, right now we're ending up with everything sorted, kind of initialized. And we start off, we inbox, we copy to that value to here, and then we check to see if that first value, yeah, we copy from wherever I is pointing at, which should be 0. And yeah, if that is 0, we've reached the end, and we want to then copy to that position. We want to bump I, and then we want to copy from our temporary storage value. We want to copy to, whoops, copy to I. Yes, we already, wait, if it's 0, first we want to grab our value, we want to put it in I. We want to bump I, and then we want to copy from there, copy that to wherever I is pointing, and then we want to reset I. Now we want to grab our value from here in Outbox, and we want to copy from then we want to set things up again. Let's see what we got so far right now, because right now it's nowhere near complete or anything. But there we go. Set up the board. We get C. We check that that's 0. Put that there. Bump it. Ah! Again, that is copying to, we want to copy to I. There we go. Yes. Yep. Put that there. Yep. Good. It's all working how I thought it would in my head. Got C, and we put it out. Yeah. I get it. This is not complete. Right. If, however, we have not reached the end, we need to compare. Right, and once we've put something in the outbox, we need to reinitialize. And that is copy from I, copy to I, copy to... this bit is not what we want to do in the initialization process. Which means we actually want to have to, we're going to have to redo that. Which is, so we want to copy from 0, copy to I. And that's re-zeroing our counter. Okay, so that resets us. However, we need to do this search, right? And so if it's not 0, we haven't reached the end, which means we need to go through and we need to check. We also actually haven't done a comparison, now I think about it. Put this here, grab C, and we basically check. Yeah, so if it's not 0, we haven't reached the end, so instead we need to copy from... Wait, we've got the value, so we need to sub X. If that is 0, we've found it, and we need to reinitialize, which is here. If it isn't 0, we need to keep going, I think. Let me see. Let's see how it all goes. Yep, A's there. Okay. Yep, reinitialized. We got our D. We go here. We check. We subtract. They're not 0. We put D in the wrong spot. So does that mean we bump I? I think it does. I'm now actually kind of puzzled by my own thinking. This is what happens when you lose the thread halfway through. Okay. Yep. A. Nope, not the same. Bump you. Get A, put that there. Oh, right. Yes, okay. Problem is that you actually have 0. I'm really tempted to do this the absolute simplest way, which is 0 out memory. So you actually just go copy from, then, rather than this copy to I business, you go copy to 0, copy to 1. In fact, I'm going to do this. This is a really... I could set this up to do it differently. Because what you can do, you're just going to do that, is you go... You just point it at each location. No, you don't. That doesn't work. Alright, fine. I'm just gonna do this. It's really pretty lazy. But if it's all 0s, then it'll automatically terminate, and I don't need to worry about having to maintain the terminator. But I should totally be able to maintain the terminator. What have I done? Okay. Let's go back to this initialization step. Thank you very much. Okay. So if it's not 0, we're going through, we're bumping, copying I, but if it's not 0, we actually we want to keep going until we hit 0. We don't want to repeat these steps, right? We want to go through and we want to get a 0. Or find something. So we actually want to bump I, copy from X, and then if this bit is not 0, right, copy from X, and then you just jump back. Whoops. In fact, this is all slightly wrong. Alright, so we start off, we've got X. We've got our value. We're checking it. Let's go back to try and work out what we're doing. Iteration is the key if you haven't already planned everything. Okay, so this is our first situation, because we start off at a terminator. And when we hit a terminator, we actually do things correctly. The trick is, we're not doing things correctly here. So here, find it, we know it's not right. But we now need to actually check this value. Right, so if it's 0, it's, you know, we found it and it's already there. If it's not 0, here we are actually treating it as we're at the terminator, obviously. But if we're not at the terminator, what we want to do is we want to keep going. So we want to bump I, so it's pointing at something else. And we then want to go back to this point, which is copy from I, and check it. And then we can go to what we want to do. Yes, I think I've got this. We'll see how we do. But pointers are so nice. They point at things, which is pretty obvious, but they let you do this. You store a location. There we go. And here we know what we're doing, and we're restoring the terminator, so we know when to stop searching. And then we check here. And here's our duplicate. There we go. Yes. Yep, and it never gets so long that this is problematic. Yes. Duplicate removal. Too many commands. Yeah, I could probably sort out some duplication. But we're not doing that on stream. Right, let's check the Alphabetizer. Please be advised this optional hallway is for advanced players only, biz. Yes, indeed. Say goodbye. Goodbye. Click. Incoming message. You will receive 2 words. One is a decoy, a false lead, a red herring. The other is part of an important message. Determine which one goes first. Okay. And if you were to order them alphabetically. Right. So, what we want is, yeah, we've got our 2 starting points. So, this is 1 and, well, actually no, it isn't. This is S1 and this is S2. I'll actually get one. I think I might try and store an E1 and an E2. But I don't know that that's sensible. Okay. So first we inbox, right? And we go copy to here, right? Well, we go inbox, if 0, skip to the next part. Otherwise, copy to where S2 is pointing. Bump, S2. We keep going. And in fact, this is why I kind of want to have this value, which I'm just going to, yeah, this isn't going to be E, this is going to be X. X is just, I want to put something here. So you copy from, you copy to there, copy from here. Okay, so here we're just initializing. If it's 0, we go on to the next word. If it isn't, boom, we've got our bits. And this actually means I know that the first string is always where it should be. And I want to put it here, actually. Thank you very much. Now, and I'll chuck you. So that puts out our first word. Then, what we want to do is copy from. Why on 21? Damn it. S2. Oh. S1. Ah! I like how it keeps the ordering. Okay, but you are S1 and you are S2. Remember it. You copy that to X. Inbox. Oh, right. Also, you go back to here. Inbox, and we okay, actually, what we should be able to do, we copy from here, we can jump to here. And if 0, this is the only problem, is because I then want it to terminate and go somewhere else. Because right now it kind of just it just repeats. Anyway, so here we get unset and then unit. Actually, if 0, what we want to, if it is 0, I would want to bump. And I want to write that 0 out. Bump X. Copy to where X is pointing. Okay. So this right now. See, unit. Units. Yep. Oh, wait. Copy 2X, then bump X. Wait, what? How? Why? Under. Oh. Copy from S2. Copy to X. There we go. That actually will take us through and put the 2 strings out. I think I just want to redo certain things. Yep, exactly. Because the problem is, when I hit here the second time, I don't get what I'm meant to do. Like, I don't get how it knows that it's already been here. Shall we say. Unless what you do is, before we do this copy from, right, we've got X in memory, and so you go sub this. If negative, get out of there. Yes, that is how you do it. And now we go on to the next stage, because this is where both strings are laid out. And we've got a start for each. So, yeah, we do need an I. So, what we want to do is we want to check values. And we want to put whichever one is first. So we want to now initialize things. So we copy from there, put it on I. Okay. Copy to I. Copy from. Actually, do we care about those anymore? Because now we've got these, we can just use these as our starts. So what we want to do is we want to copy from here. We want to sub this. And both of these are where they're pointing. And that gives you the that gives us the comparison between the first two. If it's negative, well, actually, if it's 0, we want to bump both of them, right? Bump S1 and bump S2. But if it's not 0, oh, I know why we want to go from the start. We want to keep copies. So I am gonna copy these. Okay. I don't know why I've got this copy froms. Anyway, so we go through here. What we want is, if 0, we keep going. We bump both of these. We're at the whichever, like we go to the next letter, and then we go back to our comparison. Which means we go back up to copy from S1, sub S2. Okay. Then, if it isn't 0, we need to know if it's bigger or smaller. If it's negative, then we know that if it's negative, we go down here, right? If it's not negative, then we'll do something else. But if it's negative, we know that the second number was bigger than the first number. This is the mistake I keep making because logic may not be my strong point. So the second number being bigger than the large number means the first one is the right one. And so we need to go to a loop where so this is going to be our out count. Okay. So we go to our right loop and we want to. So if the second one is bigger, what we want to do is we want to copy from I. Oops. Yeah, no, we want to copy from I and we want to copy that to out. Because that gives us the right thing. If the first one is bigger, we want to copy from X and copy to out. And then we want to jump to here. And here is where the final bit happens. The final bit is writing out our code. Writing out our word. Print. And this is actually pretty straightforward. What we do is we copy from whatever out is pointing at. We then outbox that letter. We then check if it's 0. And if it's 0, we go back to inbox because that will finish everything off. Otherwise, we outbox we outbox, yes, and we bump out, and then we go back to this, and that's our print statement. Let's see if this makes sense. Okay, first step, we write out the two words. This we've got untie and untilt. Why are you doing something? Bump X sub S2. If negative, we're skipping to the end. Oh, right, no. This actually, if we're gonna do this check, we need to copy from this and sub X. And then if it's negative. I really wish there was an if positive. That if negative is really, like, if there was an if positive, I could rework some of this. Yep, union dot. Now we begin our comparator. Wait, no, wait. Oh, I think I see my problem here. Okay, unfit. Yep, cool. Uncap. Okay. Yep, we're definitely the second word. Copy that. Yeah, copy to I. See, the problem here is I missed a step here. Copy from S2. Copy to X. Okay. And I like how it keeps giving you different like words. That is an eventuality I did not see coming. Crap. I mean, that's actually also kind of annoying that that's not allowed. But I'm not checking for the if I've hit the end. So, when it comes to this sub-statement, first I need to check if I've come to the end of either one. So, if that's 0, where does that put me? If S1 is 0, firstly what I'm going to do is I'm going to check S2, because that requires the fewest changes. So S2. S2 is 0, then we continue. Sorry, if S2 isn't 0, we continue. Otherwise, what we need to do is we need to make sure that we treat that as... so that would make S2 the shorter word, and thus it comes first. So we treat that as S2 being the shorter word, which is this one. No, which is this one. Right, if it isn't 0, we copy from S1. And if S1 is 0, then that is the same as where we go if this is positive, which is here. Okay? There's a lot more bits, and it's just, you know, this is why it's a puzzle. The And we've got 2 equal words. That's also an interesting test case. Yep, okay. So yeah, this is fine. We've got this. Oh wow! I got that in the smallest one. These programs are getting really long. And that's all we have time for. I thought I'd actually finish it today, but each of these programs is taking much, much longer. So until next time, have a great day.